Hi, thank you for joining me in this episode of GradSWE UCLA presents Women in Science, We Have the Power to Change the World. My name is Yifan, a PhD candidate from Civil and Environmental Engineering Department at UCLA. I'm also the International Student Event Officer at GradSWE UCLA. GradSWE stands for the Graduate Student Community of Society of Women Engineers. Our goal is to provide support to graduate students and help them shine in their future career. We are going to host a series of interviews to female scientists, and we hope we can encourage more women to join the community of STEM. Today we have Professor Catherine Klapperich with us. She's a biomedical engineering professor from Boston University. Her research areas include engineering medical devices to diagnose different sexually transmitted diseases at the point of care. Hi, Professor Klapperich. It's really nice to have you here in our channel.
Hi, good to see you.
Yeah, so could you briefly introduce yourself to our audience?
Absolutely. My name is Kathy Klapperich. I'm a professor of biomedical engineering at Boston University. I have a PhD in mechanical engineering, and I did my postdoctoral work in molecular and cell biology.
Yeah, so I can hear like your experience is really diverse. So because
Yes.
I watched your interview from American Institute of Medical and Biomedical and Engineering, Biological Engineering, and then I know your initial dream is to pursue journalism, which is totally different from
Totally different.
totally different. But you said a tour to engineering school changed your life. You selected material science and engineer for your undergraduate study, and then you got transferred to biomedical engineering. So I can see there's like two huge gaps between these fields. So I'm really curious, like, could you share your journey from being a material engineer and to the research you are doing right now?
Right. So when I entered undergrad, I did think I wanted to be a journalist, and I had gotten into the journalism school at Northwestern University.
Yeah.
And I was there. I grew up near there. So I was there in the summertime before my freshman year doing a tour. And I just kind of on a lark, always had been interested in science, went on a tour of the engineering school, and ended up in a room with a scanning electron microscope.
That's
Someone
the best. That's the best SEM, right? Yeah.
yeah,
Yeah.
and someone looking at not something very exciting. They were looking at cement drying,
Uh-huh.
but it was
Yeah.
really interesting to me. And I actually think the thing that sort of got my attention at that point in time was I was interested in black and white photography. And when you're looking at an SEM, you see
Yeah.
those very high contrast
Yeah.
black
Yeah.
and white images. So it drew me right in. And then I started talking with the person who was working in there, and one thing led to another. And I thought, maybe, if I'm going to have a career that is focused on scientific topics, I should study
Material
engineering
science.
for science.
Yeah.
Exactly. And at the time, back then that was 1990.
Yeah.
There were very few biomedical engineering departments, and there was not one at Northwestern. So I was interested in materials, and so studied materials engineering there. When I graduated from Northwestern in 1994, it was a really terrible job market. A lot of jobs in material science that you would traditionally get, like in making computer chips,
Oh, okay.
Motorola, IBM, none of these companies make these things in the United States anymore, but they did back
Yeah.
then. And a lot of those jobs were,
Frozen.
frozen. Exactly. They
Yeah.
weren't hiring new people. And so I started looking into graduate school, and I did my PhD in mechanical engineering, but focused on biomaterials.
Mm-hmm.
And so that's where I sort of bridged the materials into the biomaterials side of things. And at the very end of that, I started becoming interested in how new materials that I had made for orthopedic applications at the time were interacting on a cellular level in the body. So when I finished my PhD, I did go to work for a while in a biotech company, also looking at the surfaces of biomaterials. But when I went back and did my postdoc, I did that specifically in molecular and cell biology, and specifically looking at surface biomaterial interactions. So that's how I ended up starting out with,
The
materials, and ending up all the way over into bio.
So it's from big bulk material to like molecular to cell level. So it's basically like top-down approach, I would
Yep,
say.
exactly,
Wait, yeah.
exactly. And now, my students do nearly entirely molecular work.
Molecular. Wow, that's totally different from your undergraduate study, I would say. Because
Absolutely. Yep.
yeah, material science, they're more like surface, like physics, I would say. But right now it's like totally biology.
Yep.
Yeah. I know in your lab you're doing you said you're doing molecular work, but like from like an interview I watched, you're also doing like device, right? The diagnostic device, like a point of care diagnostic device, and you're trying to like deliver healthcare to limited resource settings, especially like underrepresented communities, and then especially women. You're trying to diagnose like HIV or different diseases for them, right? I got really curious because you said some of your students are from underrepresented groups, so they got motivation to study a point of care because they wanted to like help back their community and help them to diagnose their diseases. So my question is, why you got motivated to do this part of research, point of care? Yeah.
Yeah, so I did not start out in point of care. I started out being, really interested
Yeah.
in the physics of how biomolecules like DNA, RNA interact with polymer surfaces.
Yeah.
And the company I worked at in between my PhD and my postdoc was making microfluidic devices to do actually large scale, high throughput screening for
Yeah.
drug targets. But those were polymer devices that were microfluidic devices. And it
Yeah.
occurred to me back then, at the same time it was occurring to a lot of people, that you could do more than just one thing in these microfluidic devices. You could use them. Other people were starting to look at using them for what people call labs on a chip, or
Oh,
lab on a
okay.
chip
Yeah.
devices. Yeah, and I realized if we could use these devices to extract nucleic acids from complicated human samples, that we could potentially make a device that would do a molecular test for something like a sexually transmitted infection on a portable device that could find its way into any number of places in the world. And so I actually came at it initially from the device side, from like sort of seeing these tools and how
Yeah.
they were made, and then thinking, oh, wait, I could use this in a different application.
So you came from the microfluid device. Is that big? Like bigger than the point of care diagnostic you invented?
Bigger in terms
Bigger.
of size, or?
Yeah. Size, I would say size. Because like the COVID, I would say the COVID self-testing is the point of care.
Right,
Like,
exactly,
yeah,
exactly. And so what people were using microfluidics, or trying to use microfluidics for, back in the late 90s,
yeah,
early 2000s, is they were trying to come up with ways to shrink down the assays that are done in the drug discovery process.
yeah.
So either testing for toxicity or testing for target, appropriateness, and those same devices
Yeah.
can be used in point of care diagnostics. So yes, it's roughly on the same size scale,
Uh-huh.
but the real enabling thing are how inexpensive the materials are. So these things are made out of
Got it. Yeah,
commodity plastics, and even though you can make them very small and you can use very little reagent,
yeah,
they're also very cheap to make.
yeah.
And for something that you want to get to the point of care, you really want that thing to be cheap and
Yeah.
easy to manufacture.
Yeah, that's true. Like in the environmental field I'm studying, we have like point of use device, like something like I would say like a tube, you can install it under your sink and they will like treat the contaminants
Mhm.
generated from the household. So I believe they are like at the similar concept, like
Absolutely.
point of
Yep.
use. Yeah. So you mentioned initially were doing this device in a company. So you just said, oh, before you were doing your postdoc, you were like a research scientist in a
Yes.
startup company. So, and then you came back to the academia. I think that will be like super interesting for our audience because I know some of them were juggling between like industry, academia. They wanted to work in the industry and to have that experience, but they don't want to leave the academia because eventually they want to be a professor. So like why you decided to like chose to first join the industry and then why you came back to the academia?
Yeah, so these these answers aren't as
Yeah,
aren't as well thought out as the ones you just described. Though the
yeah,
reason I went to industry after my PhD is that I was really burned out
yeah.
on um, my PhD research topic, and I was also, I did my PhD at Berkeley, and that, in the Bay Area during that time. I graduated in 2000. During that time, a lot of people were leaving their PhDs in the middle to go work for startup companies, and a lot of folks had been incredibly successful
Yeah,
doing that.
yeah.
And by the time I graduated in 2000, I thought, I've got to do something different. I want to join this exciting, startup community and see what's going on. So I joined a company called Aclara Biosciences that was doing those high throughput microfluidics. And I worked there for almost 2 years. But about a year in, it was pretty clear to me that, I didn't think I was going to be happy making a career in
Yeah.
industry. Um, for me, the reason to go back was really the lack of freedom in thinking about how I like to solve problems. Like
Oh,
in the
okay.
industry setting, it was a startup. We were doing something brand
Yeah.
new, right?
Yeah.
And so, a lot of people find that exciting. Let's figure out how to get something from a project to a product.
Mm-hmm.
And, it is an exciting process. But for me, I wanted to focus more on the research side and less on the development side. And so going back to do a postdoc seemed like, that would be the path that would make me happiest in terms
Got
of the way I like to think about problems and structure them. Another way of putting it would be that I didn't follow directions well.
it. But
uh,
people
and
said like,
that
yeah, being a PI is also a startup.
it is, but you're
Yeah.
your own boss,
Oh,
right?
got it. You want to be the
And
boss.
there are
Yeah.
definitely downsides
Yeah.
to being your own boss, and there's a
Yeah.
lot of pressure, but there's also a lot of freedom. And
Mm-hmm.
I think there are a lot of things that go into, who could, which people will be more successful in industry versus which people will be more successful in teaching,
Academia.
and then also what kind of professor
Yeah.
you want to be. There are many different kinds
Yeah.
ways of being a professor. It's all depends on a lot of how you think and what you like to think about every day, and then also how you just your general constitution, right? I don't like to get up early. I still don't like to get up early.
So
And
you,
so
you you can pick your own style. Yeah. Like working style.
exactly, working
Yeah.
at a company, and having to get on the freeway by a certain time, that to me was made my life extremely difficult.
Oh,
But for
thinking
other
about the Bay
people,
Area traffic. Oh
yeah,
no.
exactly. For other
Yeah.
people, that's
I
not as much of a problem.
yeah. I was in Berkeley for a year. I didn't drive at that time, but I know some of my colleagues, they have to like get up really early to avoid the traffic. And they were like, oh, it's,
Yeah. So
yeah. So,
so for me, like the whole, you know, I don't, a lot of people will say, well, I like 9 to 5 because I like to be able to shut off work at the end of the day, right?
Yeah, yeah.
And I like to be able to, you know, have my weekend, have my free time, and have that be separate. And for me, I didn't like the constraint of having to be there during a certain amount of time, right?
Yeah, that's true. That's true. One of my, I really want to go into academia is because I really want to have my own time. Yeah.
Right.
So
And I don't mind thinking about projects that
Yeah.
I'm working on the weekend
Yeah.
or on hours or whenever I have a minute, because I have control over those problems. I'm deciding personally, I want to work on these things, right?
Yeah.
So, you know, for me, it was just a much better fit to go into academics.
Yeah.
Yeah.
So if like our audience are thinking about whether to go to industry or academia, they have to think about what working style they like and what career path they wanted to choose, right?
Exactly.
Yeah,
And it's not, you know, it's not, you know, in engineering, at least,
Yeah.
you can go back and forth to a certain extent. You know, there are different academic opportunities open to you if you go to industry first and then decide later that you want to go back. You know, if you keep in contact with your alma maters, almost
Yeah.
that, you know, you can go back and teach you know, you can, if you have a PhD, you can always go back and, you know, teach a class if you want to. You know, you can do consulting, you can do other things too that you know, you wouldn't be able to do if you hadn't gone as far and gotten your PhD. You know, you could also, some people also do a full career in industry, and then, you know, when they quote unquote retire, whenever that may be, they decide, okay, I'm going to go back and be a professor of the practice, and they don't go, you know, and then they become, you know, they don't have tenure, but they don't need tenure because they've already had it, and they already have, right?
Yeah.
Yeah.
So it's like different ways to, I would say, to select the way that we work or our career.
To engage students. I mean, if engaging students is important to you, you know, that's something that can happen at many different stages in a career as a PhD without going directly into the tenure track, right?
Yeah, that's true. Yeah, like even as a PhD student, we have like undergraduates, mentees, and like there's like different ways to like engage with students, I would say. Yeah.
Exactly. But research wise, you know, if you want to have your own research program and you really want it to be your own research program, then, you know, there's no better place than I think academics.
That's true. That's true. That I totally agree. So yeah, I have a couple of questions for our organizations, the Graduate Society of Women Engineers. So the first one is, as a female scientist, what challenges have you met in the way that you made these big decisions? For example, switching from journalist to engineers. Yeah.
Well, that one I was 18 years old. So, I, you know, it didn't really, I just knew, oh, I kind of like this. And, you know, the time is now. You know, all these resources are in front of me. And I didn't have, you know, I went to a high school where, you know, we had AP science available to us, but I didn't take any AP science in high school. So when I got to, you know, Northwestern on that day in particular, probably if I hadn't seen that lab on that day, I would have seen something else on some other day. I was like, you know, oh, wow, this is a thing that people, you know, do for their jobs. This is really exciting. You know, I want to do this. But in terms of deciding to go on and to go to graduate school, you know, I don't think it was until much later in my career did I realize that, you know, that being a woman was not the norm.
That's true. Right now I'm feeling a little bit, but when I was 18, I don't think I know anything about the career.
I mean, I knew that I didn't know any women engineers. I knew that I didn't know any women who were scientists. You know, so you know, I didn't have anyone sort of guiding me down that pathway. And certainly in college, you know, very few female professors. in my program, and only a couple of us women in my program as undergrads in my class. And so, I definitely felt out, different.
Yeah.
But there were other people who were different in different ways than I was, right? There was some, if there's a Black student, they're the only Black student in our program. So, I felt like, okay, we all have our own thing that makes us different. It's only when I started really going down the pathway of becoming an academic, and then looking back on that and thinking, okay, there are people here where I am now in graduate school who had a very different path, who had a path where there were people like them, there were people encouraging them, there were maybe parents who had been professors before them, people in their family who had PhDs. So, that's when I started to really think, okay, there's something here that I didn't have. And then, of course, the further along you get in academics, the more, narrow the pathway gets. And, the more people, the more you realize, oh, all these advantages build on each other over time. And, certainly I had advantages that other people don't have or didn't have, and those advantages also build on each other over time. And so I just think that, and there's also a certain amount of luck.
That's true.
When and where you apply for a job. I mean, academic jobs, people apply for these jobs, there are hundreds of applications for one spot, and then only 10 people get invited to interview, and then out of those 10 people maybe there's one job.
The really highly competitive nature in academia.
It's not like those 10 people who got called for the interview weren't all awesome, right? Not like out of the 400 applications that were there weren't 25, 30, 40 applications. People who would all have made great professors. There's a certain amount of luck in who's on the search committee, who's reading the applications. They hire last year? Did they hire someone last year who does exactly what you did? So it's like there's a lot of luck involved, and people shouldn't, and I realize that my job that I have now, there was luck involved with me getting that job. And that I'm grateful for that. I made the most of that. But also I recognize that there are a lot of other people who are as good or better than I am, who maybe wanted that job and didn't get it. And I think we all need to sort of think about that this is not, it's not like you say, I want to be a professor, and those jobs exist, right?
It's not, there's like a spot for you, you have to fight for it.
But also, fighting for it, and being proactive, but also acknowledging that there are some times where it's not a reflection of your self-worth.
But you have to think to be modest. I think that's one thing. So I think when I was 18, my parents expect me to study literature, like British literature or like Chinese literature, because they think it's the best thing for a girl, for a woman. I think that's like totally different. I wanted to be scientist, but they expect me to study like more literature thing because it's like easier. It's like, for women, that's but it's like stereotype. So I think it's like really, I think for me is to actually think, oh, I want to study chemistry plus biology. That's the thing that I decided to do, and then to talk to them and then to convince them, oh, that's okay. So I think, do you have any role model that you look up to when you are pursuing your career in academia?
So interestingly, I when I went to work at that that company after my PhD, my boss, serendipitously, was someone who had been a professor at a top 10 engineering school, and they had gotten tenure, and then decided after that that they wanted to go back and work in industry. And that person was my boss, right? So after a year or so, I said, oh, I'm just having a hard time fitting in to this environment. And she said, well, and I said, I think I maybe should go back to academics. And she said, oh, glad you said that, because
we all think you should.
I think you would be better as an academic as well. Like you seem very frustrated. And so she was very, helpful and guiding me sort of back toward academics, and that was, that was really great, and not like judging me, and saying, oh, you did terribly at this job. She said, no, here are your strengths. I help you, make that transition. And then there was another, that person's name was Hillary Lakritz. And then there was another person at that company, Dick Crooks, who is a professor at UT Austin, and he was consulting at the time for that company. And he and I had a number of discussions as well about, should I go back to academics? Should I be? And, and he was very, yes, you should go back and do this. And so those two people really pushed me to look for opportunities to go back. And, I ended up running into my postdoc advisor, before she was my postdoc advisor, Carolyn Bertozzi, at a social event, at a social event. And I was telling her about, I'd known her in graduate school, and I was telling her about these feelings of maybe I should go back. That I have a postdoc position, someone's leaving, you should come. Do that position, because it's in, it's in material science, it's looking at surfaces and biomaterials. And it was like, wait, what? Okay. That's crazy, right? So luck, right?
Luck,
So I immediately applied for that job and got that job. And then, she was just a huge influence in getting me back into academics. She was an incredible mentor, had already at that point, built a group. At that time, this last year, she won the Nobel Prize in Chemistry. And at that time,
I know her.
So at that
time,
at that time, her students were working on, I was there in 2002, 2003. Her students were working on the work that ended up, winning her the prize. And I was working on something totally off to the side, totally different. But just being around that group of people, and sort of getting a feeling that what they were doing was really exciting. And, everyone from the lab manager all the way to the undergrads, were working hard and together, made me really think, okay, this is like, the career that I want. This is the kind of, job I want to do.
Who doesn't want that mentor? I think everyone was your PhD mentor, not postdoc mentor. I think, it's like definitely like really like I would say like awesome experience. Better than anything.
And now, I mean, even now, in my, I didn't end up working, my own work doesn't overlap very much with the work that I did then as a postdoc, but I've still kept in contact with Carolyn these years, and, just watching her as a mentor, even before, she won the prize, she was, always, advocating for diverse teams, and advocating for, people, bringing people in who, into science, who maybe, didn't feel included. And now she has this platform where she can do that, internationally, globally. I mean, it's just fabulous.
Yeah, that's true. So, do you have any advice that you would like to give, like, all women that are thinking about pursuing STEM? Because you just said, oh, your PhD mentor wanted to like bring in more female scientists, or like more people from representative groups to the scientific world. Do you have any advice to those people and to like all of us?
So I think that, one of the things I say to my class, it's a little bit different than I say to my graduate students, but I teach a very big class of seniors. who are graduating engineers, undergraduate engineers. And I always tell them, you study this thing, and a lot of you are not going to go be engineers. You're going to
Yeah.
do, right? Maybe you're going to go to law school. Maybe you're going to go to business school, go to medical school, and biomedical engineering. A lot of kids do that, but always deep down, because you finish this degree, you're always going to be an engineer and know how to think like an engineer.
Yeah.
And in some cases, you won't be able to help thinking like an engineer.
Yeah,
And
yeah.
and that is, a superpower. And it also speaks, and if you go and you are a practicing engineer, or you go and become an academic and teach other engineers, you're also bringing, not only you bring your degree, but you're also bringing like who you are and all your experiences to that job.
Yeah, that's true. Yeah.
And now you can bring your engineering degree to that job as well.
Yeah.
And we're all, whether we're designing a medical device or a bridge or a user interface, whether we're working in a totally different field, we're always thinking about what are the design rules, what are the ground rules, what are the things we need to satisfy, how does this need to function, and then how does it serve the most people, how is it inclusive, how do we make things easier to use for all people, right?
Thinking like an engineer.
Exactly. And that can be used in any profession, right? But if a diverse group of people don't have that way of thinking, then all the solutions are going to end up being the same.
Yeah, that's true. We have to think what are the different new ways to solve the problem.
Exactly. So I tell my students, especially if they're getting frustrated and they want to quit, I say, we, the profession, we need everyone's viewpoint, right? So you're going to finish you're going to get through your degree, and it's going to be hard because engineering is hard. But when you do, what you'll be able to contribute is something that nobody else will be able to contribute, because have your unique viewpoint. You have your unique journey that you've been on up until this point, and you can inform your design and problem solving, activities with those experiences. And so I think that's pretty, I think of that as well. I think when I think about what I want to do next, I think, okay, what am I good at? What have I done to this point? What am I interested in doing? And how can I put all of those things together to make, the next thing that I do?
Next step. Yeah. So every viewpoint
to me.
Like every viewpoint counts, I think, for all the female scientists, or like all the people wanted to pursue engineers. I would say, like, they should believe in themselves that can actually make a difference to the field.
Yeah, I think so. And I think, people, when we have these conversations, I think we tend to focus a lot on, well, did you get married? Did you have a baby? When did you do this? How did you do that? Right? Like, do you take this leave? Do you take that? And it's like, yes, those things are all
important.
They're important, but they're also experiences that inform. Like, a lot of my work today, interestingly, I work on a lot of things that are adjacent to women's health. And some of those ideas and projects come out of, my own experience with infertility, my own experience, having kids and being a mom, learning about that whole side of medicine and how it works or doesn't work.
It definitely,
that is, and if I had said, oh, well, I don't want to have kids because I want to, devote my life to science. Well, then I wouldn't have ever had those experiences in my viewpoint,
exactly. So they can pursue whatever like life they wanted to have. They don't need to like sacrifice their personal life just to pursue like the science or so. Because they will give them,
I think so, but I think that the key to doing, and some people might say, but it's so hard and it's so many things, and yes, and I the key is to make sure that you have that you accept help, that you set up the support that you need in order to have the career that you want, right?
Yeah.
Whether that's, for me, I always say, I had a cleaning lady and a dog walker. And I don't cook, so I had to like figure out a way to,
Yeah. To do
feed
that. Yeah.
myself and be healthy and exercise. And, my parents were supportive when I had kids, and, all of these things, come
Yeah.
together as your support to help you do, the things
What
you
you
need
yeah.
to do. You
That's
don't do these things alone or in a vacuum,
Yeah, that's really encouraging because at my age, I'm thinking about like getting married or having kids, but I was also pretty scared deep inside. I have to admit, I was like, oh, can I pursue my career after I have kids or I have another life to take care of? I think that's definitely, yeah, there's like
Some people will say, I had friends who will say, all along the way, there were people would say, oh, I had my baby when I was in grad school because that's the easiest time because you have the most freedom. And I had people say, oh, I had it when I decided to have a baby when I was in postdoc because that's the easiest time. The most time I'm like, oh my God, I waited. I was traditional. I waited until like, I know I'm going to get tenure. I'm close to it. And then,
yeah.
But that's too long for a lot of people, like age-wise, that's too long, right?
Yeah, that's true.
And so, you have to consider those things as well. And then there are people who don't want to have kids at all. That's also fabulous.
That's oh my God. I think those people are amazing. I know like especially in Asian society, we have certain type of pressure outside, especially for female scientists, especially for like marriage and kids. So I talked to a lot of like Chinese Asian scientists, female scientists, they all said they have those concerns because that's part of their concern to pursue science. So that's totally, but you just said is just thinking about you will get a lot of help from the society, from your family, and then you can just pursue whatever career you want to have.
And some of these things are just simple, right? Like, saying, okay, having someone come clean and do laundry, that seems like it's expensive and it's not attainable, but actually it is. It doesn't cost that much if you have somebody come. And how much time does that free up for you to do, right? That's how I thought about it. I thought, well, I'm investing in this because it's going to help me, have free time to do, the things I want to do. And because you can't do 1,000 things.
You have to decide. Yeah,
exactly.
Thank you so much for all of these amazing experience, stories, and advice to our audience. Thank you so much. Yeah.
Thank you.
Thank you.
Thank you for joining me for today's episode of Women in Science. We have the power to change the world. Please hit the subscribe button and follow us to hear more stories from female scientists.